This video will cover question 5 and 6 on the final exam review for chapter 2. And number 5 says the table shows the heights y of a dropped object after x seconds. Use the table to determine the quadratic equation and estimate the height of the object at 3 seconds. So we're going to take this data and we're going to put it in a list in our calculator. So I just reminded you, we're going to hit the stat button and then go to edit. So I'm going to go to stat, enter to edit, and I'm going to list my x coordinates in list 1 and my y coordinates in list 2. Okay. Once I have that entered in, I'm going to find the equation of this quadratic by using quadratic regression. So I'm going to quit out of this screen and I'm going to go, I remind you here, we're going to go to stat, then calc, then quad reg. So stat, then go over to calc and down to quadratic regression. And it will give you your standard form equation with values for a, b, and c. So since my b value is 0, I will not have an x term. So I have my quadratic equation as y equals a is negative 16 and c is 150. So I can go ahead and I can use this equation to complete the next parts. So I want to find the height at 3 seconds. Remember, x is in seconds. So I'm going to take 3 and I'm going to substitute it in for x. Okay, so I'll do negative 16 times 3 squared plus 150. When I do that, I get 6 feet. Now I want to find the time, or my x value, at 100 feet. And 100 will get plugged in for y this time into my equation. So 100 equals negative 16x squared plus 150. Now there's a couple ways you could solve this equation. You could graph it and find the intersection at a y value of 100, or since I just have an x squared term, I can solve this using square roots. So I'm going to solve this by getting the x squared term all by itself. I'll subtract 150 from both sides. I'll divide both sides by negative 16. I'm running out of room. And then I'll take the square root of both sides. Now, normally when we take square roots to solve for x, we have a positive and a negative answer. But since we're talking about time, a negative amount of time doesn't make sense. So I'll just take the positive square root. And it doesn't tell me what place to round it to, so I'll just go to the hundredths place. It's about 1.77 seconds. All right, and number 6, we're going to write an equation for a quadratic with the given features. Keep in mind we have a few different ways we can write an equation for a quadratic. We have standard form, we have vertex form, we have intercept form. So based on the given information, we'll kind of figure out what form we want. It tells us it passes through the point 1, 3, and the parabola has a vertex of 3, negative 5. So since they're giving us the vertex, let's write our parabola in our quadratic in vertex form. So this will be given to you on the final. Vertex form, remember, is y equals a times x minus h squared plus k. And remember here that hk is your vertex. So they give us the vertex. So 3 is h and k is negative 5. So I'm going to go ahead and plug that in. So far I have y equals a times x minus 3 squared minus 5. Now to finish this problem, I need to know what is this a value. I don't know what it is until I plug in other values for x and y to solve for a. Now, since they tell us that this parabola also goes through the point 1, 3, this is an x and a y value that I can plug into this equation to solve for a. So that's what I'm going to do. I'm going to go ahead and plug 3 in for y. I don't know a, and I'll plug in 1 for x. Now I'm going to solve this for a. So I'm going to do what's in parentheses first. I'll subtract and then square this. So I have 3 equals a times, let's see, 1 minus 3 is negative 2, and negative 2 squared is positive 4. Okay. So kind of a weird way to write it. I'll rewrite this as 3 equals 4a minus 5, and then I'll solve for a. So I'll add 5 to both sides, and then divide both sides by 4. And when I do that, I get that a is equal to 2. And so that's the value that I'll plug in. My final equation of this quadratic is y equals 2 times x minus 3 squared minus 5. Remember, we don't plug in anything for x or y for our final equation. All right, so if I were just to make like a rough sketch of this, my vertex is at positive 3, negative 5, okay, and this opens up. Okay, so I know it opens up because the a value is positive. So we're going to think about this for part B. Find another point that lies on the graph of the parabola that is symmetric to 4, negative 3. Okay, so they're telling me that 4, negative 3 is also on the parabola. Okay, so I'm just doing a rough sketch here. Remember, parabolas are symmetric. And since this is our vertex is located at an x value of 3, I know my axis of symmetry is at x equals 3. And so what part B is wanting us to do is it wants us to use this point that is on this side of the axis of symmetry to find what point is on this other side here that's symmetric to it. So 4 is 1 unit away from 3. And so the point over on the left that will be symmetric will also be 1 unit away from 3. That will be at 2. And so 2 will also have that same y value as the x value of 4. So this point that's also on the parabola will be at 2, negative 3. Okay. So they were looking for us to use the parabola and that axis of symmetry to find that matching point on the other side.